Greetings to everyone. My name is Lakshmi Priyanka. Now I am going to explain about ID3. ID3 is a classic decision tree algorithm which is used for building a decision tree. It works by recursively partitioning the data based on the most informative attributes at each step. To build an ID3 decision tree, it uses the entropy of a criterion. To calculate the entropy, let us consider a data set. Now let us consider the following data sets which contains the attributes outlook, temperature, humidity, wind and play. We have to determine the entropy of the decision by using these attributes. Now we have to calculate the entropy by using the following steps. First we have to calculate the information gain. Information gain of every attribute which we consider attributes like outlook, temperature, humidity and wind. The attribute which has maximum entropy is considered as the root node. Now after calculating the entropy on every attribute, we have to choose the root node. After considering the root node, again we have to calculate the entropy of the whole data set and calculate the entropy of the individual attribute. Now let us see how to calculate the entropy. Let us consider an attribute outlook. We have to calculate the entropy of S equal to. Now we have to calculate the number of S's, number of positive and number of negatives. Based on this we have to calculate the entropy of the whole data sets. Out of 14, as we consider 9 are positive data sets, so we have to represent it as minus 9 by 14 into log to the base 2 of 19 by 14. Out of 14, 9 are positive and the remaining are we have to consider it as negative. After calculating this, we get the entropy as 0.94. Now we have to calculate the entropy of the attribute outlook, which consists the data sets sunny and entropy of overcast and entropy of rain. For calculating entropy of sunny, we have to find the number of data sets in the outlook which is named as or labeled as the sunny. So it is 5, and out of 5 we have to check whether the positive ones and the negative ones. Out of 5, 2 are labeled as S, so we have to represent it as S as follows. And out of 2, these are positive and the remaining 3 are negative, it means no. Then the entropy of sunny is as 0.971, and we have to calculate the entropy of the overcast. So according to the data set, we consider the number of outcast labeled data is 4. Out of 4, 4 are positive, so there is no negative labeled data, so the answer is 0. We have to calculate the entropy of rain. The number of rain attributes labeled as rain is 5. Out of 5, 3 are positive and the remaining 2 are negative, it means no. And the entropy of rain is 0.971. We have to calculate the entropy of the remaining attributes like temperature, humidity, wind. After calculating the entropy of all these attributes, we have to choose the attribute which having the maximum gain. As we consider the data set, the entropy of the temperature is 0.028 and the entropy of humidity is 0.156 and the entropy of wind is 0.478. So we have to decide the decision tree among these attributes and along with the attribute of outlook. Entropy of outlook is 0.97. Among these entropies we have to consider the root as the main. We have to consider the root which having the maximum gain. So let us consider or let us decide how the decision tree may as. So the outlook as root node, and it consists of the data labeled as sunny and the overcast and the rain, and the sunny labeled data sets are D1, D2, D8, D9 and D11. Out of these two are positive and 3 are negative. So we have to calculate the entropy of sunny again. Then coming to the overcast, the labeled data sets are D3, D7, D12, D13. Among these data sets, 4 are positive and 0, no one is negative. So we can directly declare that it is labeled as S, because all these are 4 are positive, nothing is negative. So we can declare it as the positive. And coming to the rain, the data sets which are labeled as rain are D4, D5, D6, D10 and D14, which are 3 are positive and 2 are negative. So we have to label whether it is yes or no. So again we have to calculate the entropy of these attributes, and after calculating the entropy we have to consider the root node as which attribute has the maximum gain. After calculating all entropies, we get the decision tree as outlook is the root node which has maximum gain and which has the labeled data sunny, overcast and rain. We can directly label overcast as because it consists all positive data items, and among sunny, after calculating the entropy we get the humidity as the root node which consists of normal and high labeled data sets, and the high labeled data sets are D1, D2, D8 which are labeled as no, and the normal are D9, D11 which are labeled as S. Coming to the rain, the data sets which are labeled as rain are D4, D6, D10, D11. Among these data sets, 3 are positive and 2 are negative. After calculating the rain entropy on the attributes of the rain, we get wind as the root node because it contains maximum gain. After calculating the entropy of wind, we have two attributes, strong and weak. Strong consists of datasets D6, D14 and weak of D4, D5 and D10. It is all the datasets of strong is labeled as no, and all the datasets of weak is labeled as S. Like this we have to calculate the entropy of each and every individual attribute and consider the root node as the attribute which has the maximum gain. Thank you.